Hello and welcome back to my channel. Thank you to everyone who has subscribed. If you haven't already, please check the subscribe channel and please like and share so I know to make more. So we're going to get to it. This is a continuation. This is part 2 of Wildcards and it is the final video for the generics collections classes. So now what we're going to do is take a look at wildcard test, and you can see here that it's very similar to the previous example. This is why it's part 2 of it, because in the previous video I spoke about numbers being the superclass and that they were auto boxed for integer and double, like int was then going to be an integer object, etc, etc. So now we have the different sections that I've created in array list of integer list, an array list of doubles, and just a generic numbers, also number list. And they're all being passed through and using the same method called sum. And this is where it is really nice, because we're using the same method, but we're going to use this lovely question mark here, which is our wildcard. So our wildcards are delimited by a question mark. If for people that are using TypeScript, we use also question marks, which I use in work sometimes for wildcards. And also there's like, so it's basically an unknown type. So unknown type extends number. So you can pass through anything through here. Now we could have also written it in a different way. We could have used the T in there as well for generic types, but we'll come to that in a second. For now, we're going to walk through just part of the code here. We have integer, integers, and then we have our array list, array even. And then we have those values then that are put into the integer list, which is part of our collection, an ordered collection. And then we have our printed out version, so integer list here, and oh, I actually have to change this to D, although it works, and double, and then this as well. So here we have our doubles, the same as before. Doubles here is then being added, put into each element, and then each element is being added to the list because the dot add is part of the list. And the same here then with numbers. And then we call our private static double sum method of unknown type extends number list, and then we pass it through and add it to the total, and then the total is the returned is returned then here. So with wildcard test, I'm going to run it first. Should be able to see it. Oh, format specifier. So if I do an undo, and here again, integer list contains 1, 2, 3, 4, 5. Total of elements integer list is 15. And the same here with 16.5 and 15.6 then is your number list. So with that then we have, if the wildcard is specified without an upper bound, then only the methods of type object can be invoked on values of wildcard type. So you have to, it has to be an object. It can't be a primitive type like int or short, byte, double, float, or long. So with that then we could also have down here, which I said a moment ago, that we could also have a different way to write our private static double sum, and we could also say let's say private static T extends number, and that would go between the static and the double like before, and then it would just be list T list. So instead of here we just have T here, and then we'd have T extends, because number is a super class for this as well. So then that because the wildcard is in the method's header, it does not specify a type, parameter, name, and so you can't use the type name then throughout, but you can with T. So I'm going to undo that now again to leave it as it was. And you can see then with each of that part, when we go through it, this is for your integers, this is for your doubles, and this is for your numbers. So let's do like a little summary of generics, because we're going to move on to a different topic after this. So for instance, generic methods enable you to specify with one method declaration multiple different sorts of related methods. So we're using sum in this instance because we're using a wildcard as well, and that sum then takes in different types. So it takes in integer, it takes in double, and it takes in number, which is both integer and double. Generic classes and interfaces enable you to specify sets of related types. So overloaded methods, which we saw at the very beginning, so writing the same method with different types, because it always checks for, it performs similar operations on different types of data. So you have to have like, okay, this is your integer method, this is your double method, but you want to be able to use one method to call all different types. So when the compiler encounters a method call, it attempts to locate the method declaration with a name and the parameters that are compatible with the argument types in the method call, which we know already. So in the overloaded, if you're unsure about overloaded methods, check out that video as well. So if the operations performed by several different methods are identical, then we can just make it into a single one. That's the purpose of generic methods. It's really nice. It makes so much sense. I love computers. So all generic methods declarations then have type specific section, and then delimited by the angle brackets or the diamond operator, I keep calling it, because we use it also in the array list. So a type parameter then is an identifier that specifies a generic type name. The type names then, the type parameters can be used as a return type. Parameter and local variables then can have generic method declarations, and then type parameter names used throughout the method declaration can match those. So it's like a matching exercise, but all type wrapper classes for primitive types implement comparable. We know this too. Comparable objects then can be used for sorting and searching using the methods in the class collections. So when the compiler encounters a method call, it determines the argument types and attempts to locate the method with the same name and parameters, which I've said multiple times now because that is really important. How does it identify what method to call? So when a generic method then is compiled, the compiler performs erasure, and I made the joke earlier of erasure being the band for those who are a little bit older or who have older siblings or parents that like that band. We're not talking about the band though, we're talking about erasure. So it removes the type parameter once it's called and replaces it with the new type with the actual types that are used. So by default, each type parameter then is replaced with its upper bound, so which is object unless specified otherwise. So when erasure is performed then on a method that returns a type variable, explicit casts are inserted in front of each method call to ensure that the return value is the same type as what is expected. Because for every single, and when in the really early videos, I described storing something like in a box, like in a physical box. If you have to be able to fit the thing in a physical box. So if you have an integer, and if it's just an integer, it's just going to fit in integers. But if you have a double, you have all these other things, so they're going to be truncated, and there's also the problem with truncation with doubles. So then we'd use big double sometimes if we were falling off the end. So you need bigger boxes to store bigger things, etc., etc. So when you expect a certain type, then you need to match it. It's all matching. So generic classes then provide a means to describe a class that is type independent in manner, and when we can then instantiate a type specific object of generic class. So a generic class declaration looks like a non-generic class. So as you saw a minute ago, you put it between static and double. So you put a T usually, and then you put T in here instead But I just showed you how to rewrite it. So here we're using the wildcard as the question mark instead for extending number, which is our superclass. So class number is a superclass of both integer and double. Number method double value then obtains the underlying double value, which is auto-boxed. When we auto-box something, we take a primitive type and we make it into an object. So wildcard type enables you to specify method, parameters, return values, and variables and so on into super types. And the wildcard question mark then is not known. It's just an unknown thing. So methods that are unknown or methods using the wildcard then as type parameters cannot be used to add elements to a collection referenced by a parameter, and that's why we'd use something like the t here instead, because then we can use the t later on. And we also know that with all of the objects that we can use comparable and we can use collection as the class as well. So that's it. Happy weekend. Looking forward to the next video and the next topic. I'm very excited. Thank you so much for watching, and stay safe. Please like, share and subscribe if you like this channel. I could do with a few more subscribers so I know to keep going. And thank you to everyone who's subscribed so far. I did not expect to get so many so quickly. Thank you. So happy weekend. Thank you. Bye.